Okay, in this video, we're going to go over the review for exam number 2, which is on Wednesday, April the 6th, and it will cover the material in Chapter 9, more specifically Section 9.1, 9.2, 9.3, 10.1, no, 10.2 and 10.3. All right, so we'll start with problem number 1, where the spinner is shown below is fun. Find each probability. So in part A, we got the probability that a number is a factor of 10. Okay. So pretty much you need to know what the factors of 10 are going to be. Okay. Use a different color marker. So here are the factors of 10. Of course, 1 and 10, and 2 and 5. So in this case here, only the 1, the 2, and the 5 appear on that spinner. So in other words, only 3 numbers appear on the spinner. So in this case here, I have to do these on a separate sheet. The probability of spinning a number that is a factor of 10, the 3 numbers, 1, 2, and 5 that are on the wheel, out of a total of 8. So that probability will be 3/8. Okay, and this is part A. Now in part B, we want the probability that the number on the wheel is a multiple of 5. Well, there's only one number that's a multiple of 5, and that's the number 5 itself. So in this case, the probability of spinning a number that is a multiple of 5 would be 1 out of 8. Okay, so that's problem number 1. Problem number 2 is this: Anne has 8 unmarked computer disks in a box, where each is dedicated to exactly one of English, Spanish, mathematics, biology, chemistry, SAT preparation, college applications, and American history. If she chooses a computer disk at random, answer the following. In part A, what is the probability that she chooses the mathematics disk? So here we're looking for the probability that Anne chooses a mathematics disk. In this case here, there are 8 disks and only one of them is marked mathematics. So the probability of choosing a mathematics disk will be 1 out of 8. Now part B says, what's the probability that she chooses a disk that is neither mathematics nor English? If there are 8 disks here, one of them is mathematics and the other one is going to be English. So if we're excluding those 2 subjects, then that means that the remaining 6 are going to be the others. So the probability of neither math or English and if there are 8 disks and we choose neither math or English, that means we can only choose the other 6 out of 8. So this will be 6 out of 8, and we can reduce 6/8 to 3/4. Okay, so that's problem number 2. All right, problem number 3. Sentinel High School was found to have the same number of students listed below. If one student is chosen from the school, what is the probability that the chosen student is a senior? All right, so if we look at this list or this table, the number of seniors there are 431. And we need the total number of students at Sentinel High School. So in this case here, if I add 472 to 548 to 549 to 431, that total is 2,000. So no, the total students here is 2,000, and there are 431 seniors at Sentinel High School. So the probability of selecting a senior, that would be 431 over 1,000. And we can leave it like this as a fraction. And whenever necessary, make sure that your fractions are in simplest form. Okay. Problem number 4 is this. A box contains 5 black balls and 4 white balls. 2 balls are drawn out of the box one by one. And in part A, we want to create a tree diagram for this experiment if the draws were made with replacement. And in part B, we're going to find the probability of the event that the 2 balls are of the same color. Then in part C, we're going to draw another tree diagram for this experiment if the draws were made without replacement. And then find the probability of the event that the 2 balls are of the same color. That would be part D. So let's start with part A in number 4. And that is to draw the tree diagram. Excuse me. And this is, in this case, with replacement. Now, what do we mean by with replacement? All right, we draw the first ball, then put it back in the box, and then make the second draw of another ball. That's what we mean by with replacement. So, on the first draw, we can draw either a black ball or a white ball. And we want their probabilities there. The probability of drawing a black ball, there are 5 black balls out of a total of 9 balls in the box. So that means that its probability will be 5/9 for drawing a black ball on the first draw. And for a white ball, there are only 4 white balls out of 9. So that probability there would have to be 4/9. Okay. Now let's look at the second draw. Now on the second draw, we can either choose a black ball or a white ball if the first ball was black, or if the second ball was white, we can still draw a black ball or a white ball. But this time it's going to be with replacement. So the probabilities will remain the same. So even if we draw a black ball first, then on the second, we can draw a black ball with that probability being still 5/9. And for a white ball, there's still 4 white balls. So probability there would be 4/9. Or if the first ball was white, with replacement, the probabilities for a black or a white ball, they're going to remain the same. So with the white ball being drawn first, the probability of drawing a black ball will be still 5/9 because it is with replacement. That means on the second draw, you're going to still have 9 balls to choose from. And then for a white ball, if it goes back in and we draw another white ball, it's still going to be 4/9. Okay. Now let's list all the possible outcomes and their probabilities here. So here we got a black and a black, or a black and a white, and then a white and a black, and then a white and a white. And let's list their probabilities here by multiplying along the branches here. For a black and a black, 5/9 times 5/9, which will be 25 over 81. And then a black and a white, 5/9 times 4/9. That will be 20 over 81. and then a white and a black, 4/9 times 5/9. That will also be 20/81. And then a white and a white, 4/9 times 4/9, which will be 16/81. Okay, so that's the entire tree diagram with their outcomes and their corresponding probabilities here. And if you were to add these probabilities together, it should, those probabilities should equal to 1. Now let's look at part B, is to find the probability of the event that the two balls are of the same color. So that means the probability of selecting 2 black balls or 2 white balls. That's going to be the probability of selecting 2 black balls plus the probability of selecting 2 white balls. So the probability of selecting 2 white balls will be 25/81. And the probability of selecting 2 white balls will be 16/81. Now, if I add 25/81 to 16/81, I would get 41/81. So the probability of selecting 2 balls of the same color would be 41/81. Okay. Now for part B, it's going to be without replacement. And we need a tree diagram for that. So this will be without replacement. And what that means here is on the first draw, we draw a ball and we don't put that ball back in the box. So that means that the number of balls will decrease and the probability will be changing when we do the second draw. Okay. So on the first draw, we can select either a black or a white. There are 5 black balls, so the probability of selecting a black ball on the first draw will be 5/9. And there are 4 white balls, so the probability of selecting a white ball on the first draw will be 4/9. And now on the second, could be a black or white. And then for this one, black or white. Now, the probability is going to change here. If the first ball that we draw is a black, that means instead of 5 black balls, there are now going to be 4 black balls. And instead of 9 total balls, it will be 8 total balls. So the probability of selecting a black ball will be 4/8. And 4/8 reduces to 1/2. Now, if the first ball was black and then the second ball was white, you're going to have still 4 white balls since the first ball was black, over 8 total. So that probability of selecting a white ball on the second draw would be 4/8 or 1/2. Now, for the first ball being white, this time you're going to have 8 balls left. The number of black balls after the first draw will still be 5 out of 8. So the probability there will be 5/8. And if the first ball is white, then instead of 4 white balls, you're going to have 3 white balls out of 8. So the probability of selecting a second white ball would be 3/8. So you can see here that your probabilities will be dropping here, will change because of the without replacement. Now let's go ahead and list all the outcomes here. So here you have 2 black balls, a black and a white, and then a white and a black, and then a white and a white. So the probability of selecting 2 black balls, that's going to be 5/9 times 1/2. that will be 5 over 18. And then for a black and a white, 5/9 times 1/2, that'll still be 5 over 18. And then for a white and a black, 4/9 times 5/8. Let's see here. I can divide 4 into 8. 4 goes into itself 1 time, 4 goes into 8 2 times. So 1 times 5 will be 5 over 9 times 2, which is 18. And then finally, 2 white balls, 4/9 times 3/8. And again, 4 goes into 8 2 times. 4 goes into itself 1 time, 4 goes into 8 2 times. So now 1 times 3 would be 3 over 9 times 2, which is 18. So these are all my probabilities for this tree diagram with replacement. And we'll use that to answer part D. That's to find the probability of the event that the 2 balls are of the same color. So that means the probability of selecting 2 black balls or 2 white balls. That's going to be adding the probability of 2 black balls plus the probability of 2 white balls. So the probability of 2 black balls here is 5 over 18 plus the probability of 2 white balls, that's 3 over 18. So 5/18 and 3/18 will be 8 over 18. And that can be reduced in simplest form to 4/9. So the probability of the event that the 2 balls are of the same color would be 4/9. Okay, so all of that was problem number 4. Let's see. Problem number 5 is this. A box contains 6 letters shown as trace, TRACED. What's the probability of the outcome, ARE, in that order if 2 letters, and that should be 3 letters. If 3 letters are drawn 1 by 1 with replacement and B without replacement. Okay, so all right, so the probability of drawing the letter A with replacement, and this is part A with replacement, that's going to be, there's 6 letters, so it'll be 1 out of 6. Now with replacement, that means that the letter that we drew on the first would go back in, so we'll do a second draw. That probability is still going to be 1/6. And for the E, also 1/6. So in this case, the probability of ARE in that order, we just multiply 1/6 times 1/6 times 1/6. That would be 1 over 216. And now part B is without replacement. That means that letter will not be put back in the box for consideration to be drawn on the second and the third. On the first one, there's 6 letters and only 1 A, so it'll be 1 out of 6. But this time, the A doesn't go back in, so that means that there are 5 letters and there's only 1 R, so it'll be 1/5. And now that letter doesn't go back in, so now you have 4 letters left. For drawing an E, that probability is now 1/4. Okay, so the probability of selecting ARE in that order Without replacement, that would be 1/6 times 1/5 times 1/4. So in this case here, this will be 1/120. So the probability of selecting A, R, E in that order, and that should be on the review sheet if 3 letters are drawn without replacement. That'd be 1/120. With replacement, it will be 1/216. Okay. All right, problem number 6, not to squeeze that down here at the bottom. Problem number 6 says here, assume the probability is 1/2 that a child born at any time is a girl and both are independent. That means one has nothing to do with the other. What's the probability of the event that if a family has 5 children, they are all girls? Okay, so the probability of one girl is 1/2. So the probability of 5 girls okay, that's going to be this. The first girl, that probability is 1/2. The second girl, still 1/2. The third, the probability of a girl is 1/2. And on the fourth, that probability is still 1/2. And for the fifth, its probability is still 1/2. So that's 1/2 to the fifth, or 1/2 times a half times a half times a half times a half, which will be 1/32. So the probability of the event, if a family has 5 children, they are all girls, would be 1/32. Okay. All right, problem number 7. Number 7 is this. If the probability of a child being a girl is 1/2, and the family plans to have 3 children, what are the odds against having all girls? Well, let's first find the probability of having all girls if there are 3 children that the family wants. Of course, the probability of having a girl on a single birth is 1/2. And then the second child that they have, its probability will be 1/2. And the third child, that probability will be 1/2. So it'll be 1/2 times 1/2 times 1/2, which is 1/8. And that would be the probability where a family plans to have 3 children and they're all girls. Now we want the odds against having all girls. All right, anytime you have odds against, that's always going to be 1 minus the probability of event A divided by the probability of event A. And in this case, we're talking about the probability of all 3 girls divided by the probability of all 3 girls. So now we got 1 minus the probability of all 3 girls would be 1/8. That's divided by, again, 1/8. Now think of 1 whole as 8/8. So 8/8 minus the 1/8 will be 7/8 divided by 1/8. And when we do the dividing here, you're going to see that these 8s divide out. So I'm left with 7/1. Oops. 7/1. Now we have to write this as a ratio, like this, as 7:1 for odds. So the odds against having all 3 girls, if a family plans to have 3 children, that odds against will be 7 to 1. Okay, so that's problem number 7. All right, problem number 8 is this. If the odds against Deborah's winning first prize in the chess tournament are 2 to 7, what is the probability of the event that she will win first prize? Okay, so here we have the odds against winning. That is 2 to 7. So for odds against, that probability is going to be this. That's going to be the n divided by m plus n. Now here, odds against in this case would be m to n. That ratio is m to n. The first number is your m, the second number is your n. So for odds against, it's going to be n divided by m plus n. Now, if it was odds in favor, then it would be m in the numerator divided by m plus n. But in this case, for odds against, your n is the second number, which is a 7, over the sum of those two numbers, m plus n, 2 plus 7. So I bring the 7 over and add 2 plus 7, which is 9. That represents the probability of Deborah winning first prize. So in this case, the probability of winning first prize would be 7 over 9. All right, problem number 9 is this. If the probability of the event happening is 82 over 95, what are the odds against it happening? So the probability of the event happening is 82 over 95. So now I want the odds against that event happening. So that's always 1 minus the probability of the event A happening divided by the probability of the event A happening. So in this case here, the event happening would be 82 over 95. So it'll be 1 minus 82 over 95. Divided by 82 over 95. Now that 1 whole represents 95 over 95. So 95 minus 82 would be 13 over 95 divided by 82 over 95. And here the 95s in this case divide out. So that means I'm going to have 13 over 82. And then that's going to be written like this, 13 to 82. So the odds against an event happening would be 13 to 82. All right, number 10. If the odds in favor of fast leg winning a horse race are 6 to 5, and the first prize is 99,000, what is the expected value of fast legs winnings? Okay. And of course, this should say and. So in this case here, we have the odds in favor, which is 6 to 5. And we want the probability of winning. This time it's going to be the M divided by M plus N. In other words, your M is going to be that first number in that ratio. So your M is going to be 6 this time because it's odds in favor. So it's going to be the first number in the numerator divided by the sum of those two numbers, 6 plus 5. And 6 plus 5 will be 11. So the probability of fast leg winning the race will be 6 over 11. But here we want the expected value of fast legs winnings. So your E, which we call the expected value, that's going to be the probability of fast leg winning, that's 6 over 11, times the amount of the first prize. That's 99,000. So what I'm going to do here is do 6 times 99,000 divided by 11. And that amount that I come up with is 54,000. So the expected value of fast legs winnings would be $54,000. Okay, so that's how I do that problem. Now number 11. Number 11 is this. Suppose the odds against winning the lottery are 53 million to 1. What is the probability of the event of winning the lottery given these odds? So here we're given the odds against. That's 53 million to 1. I'm going to write it like this. And then I want the probability of winning the lottery with those odds. So now this time it's going to be N over M plus N. So in this case, that 53 million is M, the 1 is your N. So that means that the 1 will be in the numerator. So it'll be 1 over the sum of those two, 53 million plus 1. So it'll be 1 over 53 million, 1. And I will leave that as a fraction, already in simplified form. Okay. So that's problem number 11. All right, number 12 is this. The stem and leaf plot shown below gives the weight in pounds of all 13 students in a junior high classroom. Use the plot to answer each question. In part A, they want you to list the weight of each student who weighs between 100 and 109 pounds. So here's our stem plot right here. That 10 represents the number 100. Each leaf represents the values between 100 and 109 in this case. So here we got 102, 103, 105, another 105, 106, and 108. Okay, so in part A, I just list those data values here. 102, 103, 105, another 105, 106, and 108. All right, and now part B, it says, so what is the weight of the lightest student in the class? Well, the smallest number, that's the smallest stem is 7. And for that, the smallest leaf is 4, so it's got to be 74. So that means the weight of the lightest student in that class is 74 pounds. In part C, what is the weight of the heaviest student in the class? Well, we go down to 11 and find the largest stem in 11, that's 7. So that's got to be 117. So the heaviest student in that class will be 117 pounds. All right. All right, number 13. A company employs 20 people whose ages are listed below. Answer the following questions from the information given on the list. So in part A, we're going to draw a stem and leaf plot for the set of data. And then from that, we'll answer part B, are more employees in their 40s or in their 50s? And part C, how many employees are younger than 30 years old? And part D, what percentage of the people are 50 years or older? Okay, so let's start with the stem and leaf plots. In this case here, you're going to need a vertical bar for this. And by looking at my data set, which is this right here, the smallest is 21. So I know the smallest stem would be 20. We'll start with the 2. The largest number that I see here is 64. So I know the largest stem would be 6, would be a 6. So my stems are going to go from 2, 3, 4, 5, and 6. And from here, I'm going to have to find all the numbers that has the first number of 2. That's the stem. So those numbers are between 20 and 29. So here I got 21. And then I got 23, 24, 27, 29, and 27. Okay. And let me underline these 21, 23, 24, 27, 29, and another 27. And I need to put those in numerical order. So 21 has to go first. So I put the stem for 1 to represent 21 for the 2. And then let's see, 23 is next. And then 24. And then I got a couple of 27, so I need to write the 7 down as a leaf twice, and then 29. Okay, so here I had to account for every data value in that set when I do the stem and leaf plot. And now for the 30s, from 30 to 39, I'm going to circle the numbers that has a 30. I got 34 and another 34. Okay. So I have 2 numbers that are 34, so I'll write the 4 twice. And now we go to the 40s, from 40 to 49. So here I'm going to use a different color here. It's 41, 43, 47, and that's it. So 41, 43, and 47. Let's see, put the 1 for the 41, and a 3 for the 43, and a 7 for the 47. And then for 50s, 50 to 59, let me see if I can use a highlighter for that one. Here's 51, 53, 55, 59, and another 59. So I got out 1, 2, 3, 4, 5 of those that are between 50 and 59. So let's see, 51 goes first, then 53, 55, 59, and 59. And then last are the 60s. Well, I got 61, 63, and 61 again. So another 1, a 1, and a 3. And here I need to count those leaves to see if they add up to 20. So that's 6, 8, 11. And I'm missing something here. Okay. I see it's 64. 61, 63, 61, and then 64. Yeah. So you want to make sure that you account for every single data value. So that's 6, 8, 11, 16, and 20. Okay, so that's the stem and leaf plot. All right, so we're going to use that to answer parts B, C, and D. In part B of number 13, are more employees in their 40s or in their 50s? Well, there are 3 people that are in their 40s and 5 people are in their 50s. So we can say here that more are in their 50s. More employees are in their 50s. So that's going to be part B. All right, part C. How many employees are younger than 30 years old? Younger than 30, that means less than 30 years old. Well, that's this number. That's this right here. From 20 to 29, there's 6 people that are younger than 30 years old. So 6 employees are younger than 30. Years old. And now part D. What percentage of people are 50 years or older? 50 years or older, from 50 to 59 and 60 to 69. If you count those stems, there are 9 employees that are 50 years or older. And we have to divide that by the total number of employees, that's 20. And then multiply that by 100%. Because they ask for what percentage. So 9 divided by 20 times 100 gives me 45%. That means 45% of the people are 50 years or older. Okay. Now let's move on to problem number 14. Problem number 14. Five coins are tossed 68 times. A distribution for the number of heads obtained is shown in the following table. And I want to draw a bar graph for that data. Okay. So here's a table right there. Now notice we have this from 0 up to 5. So in the bar graph, we're only treating those as categorical data with the number of frequencies. And here we look at the frequency here, and this is from 2 to 20. So when I draw this bar graph, like this, now the horizontal axis will be from 0 to 5. The vertical axis, I'm going to do this as 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, since the highest frequency is 20. So for 0, in this case, there were 2. The frequency there was 2. So the height of the bar will be at 2. Okay. Now these bars are not going to be adjacent like a histogram is. So the bar is at 0. For one head, for the number of heads, which is 1, there were 10. That frequency was 10. So the height of the bar will be at 10. So here's 10 right here. So draw another bar like this. And then for 2, it was 20. So the height of the bar will be at 20. And then for 3, the frequency there was 19. Now 19 is halfway between 18 and 20. So let me position that as halfway between 19 and 20. And then for 4, that frequency was 11. That's halfway between the 12, well, 10 and 12. And then for 5, that would be 3. So that's what the bar graph looks like. And pretty much we can label the horizontal axis as the number of heads. And then the vertical axis will be the frequency. I'm just going to tilt the paper over so I can write the word frequency. And you can give this a title. Okay. Let's say 5 coins tossed. Okay. Okay, so in problem number 14, that's how you construct a bar graph. All right, problem number 15. Problem number 15 states, use the pictograph below to answer this question. How many outs did the player have? So here's what the pictograph looks like. And of course, this tells you what each baseball represents in this case. So each baseball represents 35 times at bat. How many outs did the player have? So if we look under the row for outs, we see 1, 2, 3, 4 baseballs, and each baseball is 35 times at bat. So if I multiply the 4 times 35, that represents 140. So in this case here, this player had 140 outs at bat. Okay. All right, number 16. The graph below shows the number of snow shovels sold in winter months at a store in 2010 and 2013. So the line graph in red represents 2010, while the graph in blue represents 2013. So in part A in problem 16, during which month did the store sell the most snow shovels in 2010? So let's look at the red broken line graph here. The most snow shovels would be right here. And the month that happened would be in January. Okay, so to answer part A, January was the month where the most snow shovels were sold. And that was in 2010. Now, part B states, during which month did the stores sell the fewest snow shovels in 2011? So we had to look at the blue graph here. All right. Now, the dot that's the lowest will have to be right here. And the month where the fewest snow shovels were sold in 2011 was the month of March. Okay. So that right there was problem number 16. Problem number 17. From this graph below, what type of association exists for the data? All right, notice that the graph, if you go from left to right, these dots are increasing from left to right. So that tells me that this graph has a positive association. So the graph that I showed you here has a positive association. Now, I'll explain this. If the points fell from left to right, then you have a negative association. Now, if you have points scattered all over the place, then that means that there is no association for those points or for that graph. Okay. And finally, problem number 18 is this. If a trend line had the equation y equal 3x minus 6, 3x plus 6, y equal 3x plus 6, what y value would you expect to obtain when x has the following value? So here, I'll write the equation y equal 3x plus 6. And in part A, you're told you have -2. So that means in this case here, your x value would be -2. So that means y is equal to, it would just substitute the x with that -2. So it'd be 3 times -2 plus 6. And 3 times -2 would be -6. -6 plus 6 would be 0. So for x equals 2 for that trend line, I would expect to have a y value of 0. And in part B, 14. So that would mean x will be equal to 14. And to find out what y is, again, we just substitute the x with 14. So it'd be 3 times 14 plus 6. And 3 times 14 would be 42. 42 plus 6 would be 48. So at x equals 14, I would expect to obtain a y value of 48. And then part C has 0. That would mean x is equal to 0. So we just substitute the x with 0 in y equal 3x plus 6. So this will be y is equal to 3 times x, which is 0, plus 6. And then 3 times 0 is 0. 0 plus 6 will be 6. And finally, part D, where you have 6, That will mean x is equal to 6 in this case. So that means y is equal to 3 times x, which is 6, plus 6. 3 times 6 will be 18. 18 plus 6 would be 24. So for x equals 6, I would expect to get a y value of 24. Okay. So that completes this video for the review for exam number 2 on Wednesday, April the 6th. Feel free to reach out to me if you have any questions about any of the problems that were presented in this video.